In the beginning, before the universe had carved its familiar shapes of spirals and clusters, before light had mapped the contours of cosmic silence, there was only the trembling of energy across an infinite void. From that trembling, galaxies bloomed like frozen fireworks, scattered islands of stars bound by the invisible embrace of gravity. For billions of years, they formed according to patterns written deep into the bones of physics. Spirals curling like seashells, ellipticals swollen like dying suns, dwarfs trailing like sparks across the fabric of space. Each galaxy obeyed rules as ancient as the cosmos itself. Mass gathered mass, dark matter scaffolded form, stars were born and burned and died in rhythms that repeated across the heavens. But among these expected symphonies of order, there comes a discordant note, a trembling anomaly. One galaxy that should not exist, not by the laws of our textbooks, not by the scaffolding of gravity, not by the silent architecture of dark matter, halos that cradle every cluster of stars. And yet, we see it. Its light has crossed millions of years of emptiness to strike our telescopes, undeniable, unshakable. It is there, in defiance of what should be possible. Imagine it. A collection of stars drifting loosely together, their motions whispering that nothing is holding them as it should. Or perhaps the opposite. A galaxy too tightly bound, too perfect, as though crafted by some invisible hand that ignored the universe's standard tools. In its glow, astronomers saw the face of contradiction. The rules of cosmology, painstakingly assembled since Einstein bent space-time with equations, seemed to falter before its presence. A galaxy that should not be, but is. The first glimpse was not marked by fanfare or certainty. It was a faint smudge on a detector, no brighter than the ghost of an old candle flame. Observers. Observers, tired from long nights at the telescope, marked it, measured it, catalogued it, never imagining they were writing the first line in a story that would unsettle the very foundations of physics. For in that smudge lay the weight of a paradox, and paradoxes have always been the most dangerous of truths. To understand why this one galaxy is so impossible, one must first understand the fragile balance that makes any galaxy possible at all. Gravity, left to itself, is relentless. It pulls, it collapses, it drives matter into ever tighter knots. But in the early universe, gravity did not act alone. It worked in partnership with something unseen, something no photon could reveal. The dark matter that filled the cosmos like an invisible web. Without it, the gas of the early universe would not have clumped fast enough to form stars and galaxies in the brief cosmic window allowed. Without it, the shining structures we see in the night sky would never have formed. Every galaxy we know, from the majestic whirlpool of Andromeda to the pale dwarfs that trail the Milky Way, sits in a cocoon of dark matter. It is this unseen halo that provides the gravity to hold its stars in place, to keep its shape against the violence of cosmic time. Remove the dark matter, and the galaxy dissolves. Remove the dark matter, and the stars drift apart like grains of sand blown by a timeless wind. And so, when astronomers first measured this anomaly, when they looked for the telltale signatures of the invisible halo, they found nothing. The stars moved not as though they were swimming in a vast dark sea, but as though they were alone, untethered. The galaxy appeared to have no dark matter at all, or at least not enough to explain its form. The impossible lay bare. A galaxy that should never have formed, that should never have held together, glowing steadily in defiance of theory. It was like finding a tree that grew without roots, or a city standing without foundations. A contradiction so profound that even to acknowledge it felt dangerous. Was it an error of measurement? A trick of perspective? Or was it the first whisper that the cosmos, vast and ancient, holds secrets that mock our confidence? In the silence of observatories, scientists debated. Equations were tested, revised, recalculated. Some believed the anomaly would dissolve under scrutiny, as so many strange detections had before. But others felt the shiver of something deeper, a truth slipping like a shadow beneath the surface of understanding. For if one galaxy could exist without the scaffolding of dark matter, perhaps dark matter itself was not what we believed. Perhaps the very architecture of the universe was flawed, incomplete. And so begins our journey, not just across space to a galaxy that should not be, but across thought itself, into the fragile realm where certainty collapses and mystery rises. A galaxy like a ghost, shining with stars it should never have formed. A galaxy that asks the question no physicist wants to hear. What if everything we know is wrong? The image lingers, a faint smudge of light on a detector, carrying with it the weight of cosmology's undoing. A whisper in the darkness of the universe, speaking of a structure that by all rights should not exist, but does. The impossible, made visible. The smudge of light, once dismissed as unremarkable, began to transform under scrutiny. A telescope's gaze is not unlike the human act of remembering. The longer one stares, the clearer the patterns become, until what once seemed faint emerges with startling clarity. Night after night, as astronomers returned to the sky, this dim structure revealed its secret contours. Stars scattered like embers, faint clusters shimmering, a faint elongation suggesting not a star, not a quasar, not the accidental overlap of cosmic bodies, but something larger, something coherent, something that whispered the unmistakable geometry of a galaxy. Yet galaxies are not simple. To glimpse one is not to know it. Galaxies are ancient biographies written in light, and to read them requires patience, precision, and faith. Spectrographs turn toward the faint glow, breaking its light into threads of color. Each line carried a story, the chemical birthmarks of stars, the velocity of their motions, the redshift of a structure moving away with the expansion of the universe. Slowly, the identity of this object took form. It was real, it was distant, it was luminous, but it was also strange. For in its heart, where one would expect the density of a nucleus, there was only transparency. Its stars seemed loose, untethered, spread across a space so fragile that any minor perturbation should have torn it apart. Yet there it was, whole, serene, defying the predictions etched into cosmological models. It was not merely unusual. It was, in the language of science, anomalous. And anomalies are both the curse and the gift of progress. The first murmurs of disbelief echoed through research halls and conference rooms. Some argued it was a trick of perspective. Perhaps two galaxies overlapped in the line of sight, creating an illusion. Others thought it might be a remnant of a galactic collision, a shredded system in its death throes, captured mid-dissolution, but the data whispered otherwise. The velocities of the stars did not match two separate entities, nor did they match the violence of a torn remnant. Instead, they hinted at something stable, impossibly stable. The language of disbelief is cautious. Scientists rarely say, "This cannot be." They say instead, "This should not be." And so the galaxy was marked as such, a system that should not be. Too few stars to justify its size, too little gravitational glue to hold it, too transparent for its mass, yet serenely adrift in space as though nothing were wrong. Behind the measurements lay a deeper unease. For decades, the standard model of cosmology, the Lambda CDM framework, had guided thought. It was a model that depended on two invisible actors, dark matter, the unseen substance providing galaxies their skeleton, and dark energy, the mysterious force accelerating the universe's expansion. Together, they accounted for nearly 95% of the universe, leaving only a small fraction to ordinary matter, the stars and planets and people we see. Every galaxy discovered until now had played its role, confirming the necessity of dark matter. Their rotations, their gravitational lenses, their clustered distributions, all bore silent testimony to the invisible halos enfolding them. To find a galaxy stripped of such a halo was to find a body stripped of bones, yet somehow standing. And so, quietly, a storm gathered. For if this galaxy was real, if its properties held under deeper scrutiny, it meant that one of the universe's greatest assumptions might be wrong. Either galaxies could exist without dark matter, or our understanding of dark matter itself was flawed. Both possibilities were unsettling. The discovery did not arrive in headlines or breaking news. It grew like a slow tide, spreading through academic papers, whispered across conferences, debated in seminars. Those who stared longest at the data began to feel its gravity. Not the galaxies, but the weight of its implications. Here was not just an object. Here was a question, carved in starlight. Consider the metaphor of a ship at sea. A galaxy is a vessel, its stars the sailors, its dark matter the hull that holds them together. But here was a ship with no hull, only sailors drifting in unison, a vessel that by all known principles should have already sunk. Yet it sailed. How? The first to suggest answers reached backward into cosmic history. Perhaps this galaxy had once been ordinary, cradled in its dark matter halo, only to be stripped bare by gravitational encounters. Perhaps a nearby giant had pulled away its invisible mass, leaving only the luminous stars behind. But even that seemed strained. How could stars remain without the gravity of their unseen companion? How could a system persist after such a violent theft? Others pointed instead to flaws in our assumptions. What if dark matter did not behave as we thought? What if it was not a passive, invisible scaffold, but something dynamic, something that could slip away under certain conditions? What if, more daring still, dark matter did not exist at all, and what we mistook for its hand was only the echo of a deeper law of gravity yet to be written? The debates sharpened, not with hostility, but with the sharpened awe of scientists confronting mystery. For in truth, they were not only debating the fate of a galaxy, they were debating the fate of knowledge itself. Every equation in physics is provisional. Every model is a lantern carried into darkness. And here, in the quiet presence of a faint galaxy that should not exist, the darkness pressed back. To speak of such things is to speak of humility. Humanity builds castles of theory, towers of equations, only to find them sometimes undone by the faintest light. The cosmos has no obligation to obey our certainties. It writes its truths across billions of years in patterns too vast, too intricate, too strange for any single mind to contain. To stand beneath its skies to be reminded that we are apprentices, forever at the beginning. And so, astronomers watched. They measured again. They planned new observations. Each star within the galaxy became a voice, its motion a testimony. Each voice told the same story. Something is missing, and in that absence, they heard the echo of possibility. That perhaps dark matter was not the silent monolith they had believed, but something more elusive, more complex, more fragile. The galaxy drifted on, silent and uncaring of its role in our drama. Its light, already millions of years old, whispered across the void, indifferent to the questions it raised. For the universe is not troubled by what we do not know. It is only we, fragile minds bound to a fleeting world, who tremble at the sight of something that should not exist but does. And so the smudge of light, the faint, impossible galaxy, became more than a discovery. It became a mirror, showing us not only the strangeness of the cosmos, but the strangeness of our need to understand. It reminded us that even now, after centuries of science, the universe is still larger than our imagination. The question lingers. If a galaxy can exist without dark matter, What else waits beyond the edge of our understanding? What other structures, hidden in the depths of sky surveys, shine quietly in contradiction to the rules we trust? For the cosmos is not a solved equation. It is a riddle whispered in the language of stars, and sometimes that riddle takes the form of a galaxy that should not be, but is. The galaxy did not announce itself with brilliance. It was not a blazing quasar or a luminous spiral like the Milky Way, broadcasting its existence with clarity. It was faint, quiet, and fragile, like a whisper drifting across a desert of silence. Yet in that quietness lay a dissonance strong enough to shake theory itself. Sometimes the greatest revolutions come not with thunder, but with silence. As the discovery matured, astronomers traced their steps carefully, for history is littered with illusions. A phantom star, a miscalculated orbit, an error in calibration. Each has led scientists astray in ages past. They knew the danger of rushing to conclusion, of letting the hunger for the extraordinary eclipse the discipline of patience. And so they returned again and again, peeling back the layers of data with almost surgical precision. The stars within this ghostly structure were mapped one by one. Each tiny speck of light carried with it the memory of its velocity, its position, its lineage. To measure their dance was to write the biography of the galaxy itself. And here the first undeniable truth emerged. The stars moved too slowly. In an ordinary galaxy of similar size, stars whip around with velocities betraying the hidden grip of dark matter. They spin faster than visible mass alone could allow, pulled by the invisible hand of a vast halo. But here, the stars drifted almost lazily, their motions suggesting only the gravity of the stars themselves. No invisible mass, no hidden skeleton. The realization struck with the weight of inevitability. This was not a mismeasurement. This was not an illusion. This galaxy, with the serene name assigned to it in a catalogue, truly lacked the dark matter that should have been its foundation. The idea echoed outward, reaching the halls of universities, the conversations of cosmologists, the restless debates of those who dedicate their lives to the unseen. Was this proof that dark matter, so long the trusted partner of cosmic formation, was misunderstood? Or was this an outlier, a strange exception that nevertheless affirmed the rule? It is one thing to doubt a theory in the abstract, quite another to see the doubt written in stars. Imagine standing in a library where every book is bound in leather, and then finding one bound in glass. The words inside may be familiar, but the binding itself tells you that something is different, that something fundamental about your expectations has been broken. Such was this galaxy. Its very existence proclaimed that the universe had more variety than we dared to imagine. Some sought refuge in the possibility of interaction. Perhaps this galaxy had once wandered close to a massive neighbor, stripped of its dark matter by gravitational tides, yet somehow spared its stars. Others leaned toward models of exotic physics, whispering of modifications to Newton and Einstein. Perhaps gravity itself, at the faint edges of acceleration, behaves differently. Perhaps dark matter is only a placeholder for laws not yet written. But behind every speculation was a quieter truth. The mystery deepened, not diminished. For every answer given, new questions arose. If dark matter can be stripped away, why do most galaxies retain it? If gravity bends differently than thought, why do most galaxies still obey the old rules? If exceptions like this exist, how many more lie hidden, waiting to be seen? In the depths of night, as telescopes turn their long eyes skyward, the philosophical weight pressed in. It is not only the universe that feels vast, it is also ignorance. Humanity clings to its certainties like sailors to a raft in a boundless ocean. And sometimes the discovery of a single strange object is enough to remind us how small that raft truly is. For those who studied the faint glow, the galaxy was not merely an object. It became a symbol of humility. The universe had once again whispered, "You do not yet understand me." The story of discovery is also the story of those who make it. Behind the data are the sleepless nights of observers, the quiet hum of instruments, the long hours of calibration. There is a kind of devotion in science, an act of faith that the universe will reward patience with revelation. And here, the revelation was both unsettling and beautiful. A system that should not exist, a cosmic poem that rewrote its own meter. There is beauty in impossibility. To stand before a paradox is to stand at the edge of meaning, to feel the vertigo of uncertainty. The faint light from this galaxy traveled millions of years, crossing the abyss to deliver to us not certainty but a question. It is as though the cosmos itself conspires to keep wonder alive, ensuring that with every answer we find, there is always a new riddle waiting. This is the essence of discovery, not the end of mystery, but its renewal. And in this renewal, humanity finds purpose. For what is science if not the endless act of approaching the infinite, of carving sense from chaos, of daring to ask questions that may never be answered? The galaxy drifts on, silent, indifferent, its stars burning quietly in their remote darkness. It does not care that it has unsettled us. It does not care that it has made us question the scaffolding of reality. It simply is. And in that being lies the truest lesson of the cosmos. Existence does not need our permission, nor our understanding. It only needs itself. As Chapter 1 closes, we are left not with clarity, but with the haunting echo of the question first asked. How can a galaxy exist when all we know says it cannot? The smudge of light has grown into a beacon of mystery, a reminder that the universe, for all our models and theories, is still untamed, still strange, still greater than the boundaries of thought. It began as a discovery, it became a shock, and now it begins to unravel the very fabric of certainty, opening a path into the unknown. Discovery is never just the unveiling of a fact. It is the intersection of chance, persistence, and human longing. The strange galaxy that defied expectation was not found because someone was looking for impossibilities. It was found because astronomers were, as always, cataloguing the sky, chasing the ancient light of structures too faint for the naked eye. This is the paradox of discovery. The extraordinary is often uncovered in the pursuit of the ordinary. In the late nights at observatories, researchers stare into monitors as the sky unfurls in pixels. To most, these images seem lifeless, dots and smudges without meaning. But to a trained eye, each smudge is a signature. A compact sphere hints at a distant cluster. A spiral blur reveals a galaxy seen face-on. An elongated streak becomes a galaxy viewed edgewise, its arms like blades of light stretching into the dark. It was in such work, routine and meticulous, that the galaxy first appeared. No explosion, no shout from the universe, no sudden blaze of strangeness. Just a subtle glow recorded on the detectors, added to a list, compared with databases, and filed for further observation. The astronomers who first marked it were not expecting to rewrite cosmology. They were simply performing the patient work of mapping the heavens. But science advances in two movements, the steady accumulation of data and the rare, disruptive appearance of anomalies. And when anomalies surface, they demand attention. In this case, the galaxy's structure was immediately peculiar. Its stars were faint, dispersed, lacking the dense heart common to most galactic cores. It appeared almost translucent, as though someone had taken a brush of light and dragged it lightly across the canvas of space. Such faint galaxies are not unknown. Astronomers call them ultra-diffuse galaxies, large in size but dim in brightness, their stars stretched thinly across vast volumes. Yet even among this strange family, this one stood apart. Its mass seemed wrong, its light seemed wrong, and, as later measurements would prove, its lack of dark matter was not merely unusual. It was impossible. To understand the weight of this discovery, one must step back into the history of astronomy. For centuries, humanity believed galaxies were not even separate entities. To ancient astronomers, the Milky Way was a cloudy band, a river of stars that belonged to the heavens themselves. It was only in the 20th century, with the work of Edwin Hubble, that we came to understand galaxies as island universes, each one a collection of billions of stars adrift in a sea of cosmic expansion. Hubble's revelation was revolutionary. The universe was not confined to the Milky Way, but expanded endlessly, with galaxies as numerous as grains of sand. Yet in discovering this vastness, Hubble also uncovered laws. Galaxies did not scatter randomly. They obeyed redshifts, velocities, correlations between size and brightness. They were not chaos, but order, following patterns that seemed as unshakable as gravity itself. And so the idea that a galaxy could exist outside those rules, without the dark matter scaffolding that every theory insisted upon, was more than strange. It was heretical. It was as though the universe had quietly set a trap for certainty, luring us with patterns only to shatter them with exceptions. The astronomers who first studied the faint smudge could not have known the storm it would ignite. They were careful, cautious, unwilling to proclaim more than the evidence allowed. Yet even in those early days, one can imagine their awe. To sit at a console, to stare at a galaxy that by all logic should not be there, is to feel a chill as old as science itself. The chill of realizing that knowledge is incomplete. For discovery is not only about finding what is there, it is about confronting the impossible and asking, if this exists, what else might? The telescope's cold detectors captured the light. The spectrographs separated it into lines. The astronomers wrote their numbers, built their graphs, checked their uncertainties. Behind these technical acts lay the oldest human impulse, wonder. The galaxy had been born billions of years ago in the silence of a young universe, only to drift through eons until its faint glow struck our instruments. That glow carried with it a message, though one written in the cryptic language of paradox. We had asked the cosmos to show us its order. Instead, it showed us its exception. Discovery has always been a dialogue between the universe and those who dare to listen. The first voice came faintly, almost unwilling to be heard, in the form of a dim and ghost-like glow. Astronomers leaned closer, their instruments passing light that had traveled for millions of years. The numbers whispered of distance, of motion, of something real, and yet those same numbers also carried contradiction. A galaxy was there, but it did not obey. The early analysis unfolded like an unmasking. Each measurement stripped away the possibility of illusion. Redshift confirmed its distance. Brightness confirmed its stars. Its profile, diffuse and fragile, spoke of a structure both immense and transparent. There could be no doubt this was a galaxy, but one whose balance was unlike any other seen before. The scientists who faced this data were heirs to centuries of cosmic exploration. They knew the stories of discovery, of how Galileo's telescope shattered the medieval heavens, of how Newton carved gravity into law, of how Einstein bent space-time into a fabric that held the stars. They knew that every paradigm eventually faced its crisis, when the universe revealed something it had hidden in plain sight. And now, through their detectors, came the hint of such a crisis. In conference halls, voices debated. Was it an error in calibration? A misinterpretation of velocities? Could it be two galaxies overlapped, creating a trick of light? Yet the deeper the scrutiny, the more the anomaly hardened. No, this was not illusion. No, this was not error. This was something new, and something new is always dangerous. To admit its reality was to risk shaking the pillars of cosmology. For every model that charted the evolution of galaxies depended on the invisible scaffolding of dark matter. It was dark matter that explained the velocity curves of spiral galaxies, that justified the clustering of matter in the young universe, that accounted for the hidden weight holding galaxies together. Without it, the cosmos we know would collapse into contradiction. And yet here was the contradiction, staring back through the silence of space. A system too fragile to exist, but existing. A galaxy that seemed to lack the very essence of what made galaxies possible. One cannot underestimate the psychological weight of such a revelation. To scientists trained to find order, it is almost unbearable to find disorder instead. The stars within this ghostly structure moved too slowly, their gravity too weak, as though they floated without anchor. No invisible mass pressed upon them, no unseen halo guided their path. It was as though nature had staged an act of defiance. And still, the question burned, how? Was this the product of violent history, stripped of its dark matter by the tidal forces of some cosmic encounter? Or was it a sign that our equations were incomplete, that we had mistaken the shadow for the substance, and that dark matter was not what we believed? The galaxy, silent and ancient, offered no answer. Its stars continued their slow, improbable drift, unaware of the turmoil they had ignited on a small planet billions of light-years away. It is not the stars that feel paradox, but the minds that gaze upon them. This was the shock of science, to realize that the universe had betrayed our trust. The story of the impossible galaxy deepened as more eyes turned toward it. Night after night, telescopes tracked its faint shimmer, parsing what little light it gave. Each observation, each recalculation, stripped away layers of doubt until only one fact remained. This was not a trick. The galaxy was real. Its structure was real, and its defiance of theory was undeniable. In the discipline of astronomy, every anomaly demands patience. Data is tested. Instruments are checked, backgrounds are subtracted, biases hunted. The search for error is relentless, for extraordinary claims require extraordinary care. Yet the more carefully they searched, the clearer the enigma became. The stars within this ghost-like system did not spin fast enough. Their motions traced no hidden weight, no unseen hand pulling them into orbit. There was no dark matter here, or at least none in the quantity that all models required. To confront this truth was to feel the ground shift. For decades, the idea of dark matter had been more than hypothesis. It had been a cornerstone. Galaxies everywhere revealed its grip through their motions. Clusters bent light with its mass. Simulations of the early universe relied on its invisible scaffolding. Without it, the structures of today could not have formed, and yet this faint, fragile system seemed to say otherwise. Some scientists argued that perhaps this was an exception, a rare survivor of cosmic violence. Maybe it had once been ordinary, wrapped in its dark halo, only to be stripped bare by an encounter with a massive neighbor. Others wondered if our grasp of gravity itself was incomplete, if perhaps at the faintest accelerations, Newton and Einstein gave way to new laws. But each proposal brought its own unease, for none explained everything, and each required the rewriting of what once seemed certain. The galaxy itself remained silent, indifferent to the storms of theory it stirred. Its stars glowed softly in their improbable unity, unaware that on Earth they had become the seeds of controversy. It is always this way. The universe exists as it is, while humanity trembles at the edge of its meanings. Here, then, was the first true crack in confidence, not merely a curiosity, but a challenge. If a galaxy can exist without the invisible weight we call dark matter, then perhaps the universe has been speaking a language we have only half understood. Light is an ancient courier, and in its message the impossible sometimes travels unnoticed. Then a human hand touches the data, and quiet becomes thunder. The shock did not arrive as spectacle. It arrived as a sum of small certainties that refused to add up. A telescope harvested photons that had crossed a wilderness of time. Spectrographs tease those photons into lines. Hydrogen's soft confession, calcium's faint recall, the fingerprints of iron and magnesium in elderly stars. Then came velocities, the invisible grammar of motion, drawn from Doppler shifts measured against the patient clock of the cosmos. From these ingredients, astronomers assembled a portrait of a galaxy so diffuse that starlight seemed poured thinly over emptiness, and yet so coherent that its boundaries made sense to the eye. All was ordinary until the motion of the stars spoke. They moved too gently. They orbited with a restraint that mocked the expected pull of an unseen halo. Where there should have been weight, there was merely light. The disquiet ran along well-worn lines. In the standard view of creation, structures took shape inside halos of cold, collisionless dark matter, vast invisible spheres that gathered primordial gas like dew on spider silk. Stars were born within that shelter. Spirals and ellipticals grew from mergers and tides, their destinies negotiated inside the gravitational wells of those halos. Simulations, the digital universe is inhabited by particles and laws, had predicted this architecture for decades. And the sky agreed. Rotation curves of ordinary spirals rose and stayed flat, as if held firm by the patient hands of an unseen mass. Galaxy clusters bent background light into arcs and rings, revealing reservoirs of matter otherwise untouchable. The cosmic microwave background, a fossil whisper from when the universe was young and hot, boasted ripples whose sizes and spacings only made sense if most of existence were dark. The invisible had become indispensable. No model without it could carry the world from fire to filaments. But here, within the faint and tremulous glow of a low-surface brightness disk, call it a shadow galaxy, call it a ghost ship, the stars did not feel the grasp they were supposed to. The dispersion of their velocities was small. The gravitational well measured by their motions was shallow. If the galaxy's light were weighed and its stars counted with caution, ordinary matter alone could account for its binding. The ledger balanced without invoking the dark, and that was the shock. Not merely a numerical oddity, but a philosophical trespass. The world had grown used to the idea that its deepest truths were invisible. Now a visible, fragile thing had appeared that seemed to manage without those truths. The paradox landed quietly, and the quiet was deafening. Suspicion bloomed the way it must. Distance, the first culprit, was interrogated. If the galaxy were closer than assumed, then its size would shrink, its mass would fall, its need for hidden matter would fade into banal adequacy. Distances to such wisps of starlight are not trivial. One cannot hang a yardstick on a star. Astronomers turn to the tips of red giant branches, to standard candles whose peak brightnesses are well behaved, to surface brightness fluctuations that treat the granularity of stellar fields as rulers, to the delicate parallax ladders calibrated in the Milky Way and stretched into the deep. They checked associations with brighter neighbors, mapped out streams and satellites that might betray a shared history, examined the registration of peculiar velocities against the Hubble flow. If a galaxy could hide by leaning toward us, it might trick the calculations that exposed its defiance. But the numbers held their ground within uncertainties that could not smother the scandal. Then came the instrument. If spectra were too coarse, if seeing smeared velocity gradients into false calm, if the light from diffuse star clusters tricked the algorithms that extract dispersions from tired pixels, then the galaxy's apparent gentleness might be an artifact carved by human limitation. So they returned with sharper eyes, with longer exposure times, with instruments whose teeth bit deeper into the spectrum. Keck gathered the night. VLT gathered the night. Hubble's vision, unsullied by air, mapped globular clusters like floating beads whose motions could pass sentence on the mass. The Dragonfly telephoto array, its lenses optimized to drink surface brightness where most telescopes cannot taste it, revealed a geography of glow that said the galaxy was not merely a smear of overlapping trespassers along the line of sight. JWST, turning its sensitivity to the ancient red, could reach the low luminosity stars whose whisper strengthens or weakens every mass estimate. Only after these rituals of doubt did the reality harden. The motions remained soft. The invisible hand remained light. What law had been broken? The question is as old as curiosity. In this case, the law was not a statute carved on stone, but a likelihood sustained by 1,000 agreements between observation and theory. The LCDM cosmos, lambda for dark energy, CDM for cold dark matter, had delivered a coherent past. The spectrum of ancient radiation, the web of galaxy clustering, the statistics of lenses, the dance of satellite systems around massive hosts. One galaxy is not an empire. A rule is not undone by a whisper. But rules are made by stories, and a story that allows exceptions must explain them. A galaxy without dark matter, if truly born that way, would demand a different path from gas cloud to starlight. Some special history in which the gas uncoupled from its dark womb and yet found a way to settle, cool, ignite, and persist without the ballast. A galaxy stripped of dark matter, if torn that way, would demand a crime scene. Tides, encounters, resonances, shocks. The sky is full of culprits, massive neighbors with appetites, clusters with tides, filaments that funnel and shear. Perhaps the galaxy was once ordinary and had been robbed. But robbery leaves fingerprints, streams, asymmetries, truncated profiles, stellar populations with bruises in their ages and metallicities. The autopsy found hints and silences, not verdicts. The alternative, modify the law itself, arrived, as it always does, with audacity. If gravity behaves differently in the regime of low acceleration, if the relation between mass and motion bends away from the Newton-Einstein story when fields are faint, then a galaxy could masquerade as dark matter-free simply because no such matter exists anywhere. The anomaly would be the echo of a deeper rule. The modified gravity ideas are careful and cunning, able to slide into some data with elegance. They explain rotational curves with an economy of assumptions that feels like Occam's nod. But they also stumble among the ruins of clusters where hot gas and lensing demand mass that refuses to be written as geometry alone. They sweat under the precision of cosmic background fluctuations whose peaks and troughs prefer a substance that gravitated but did not shine. They create as many puzzles as they resolve. And thus, even in the shock, the balance of evidence held the invisible as real, while leaving a niche for doubt with teeth. The shock, then, became a sequence of questions rather than a collapse. If the galaxy had little dark matter, how little? What was its stellar mass-to-light ratio, and how did the ages of its stars, their metallicities and their initial mass functions, conspire to hide or reveal the true weight of the luminous? Could a population richer in low-mass, faint stars mimic the presence of extra matter? Could binaries or rotation viewed face-on counterfeit a calm dispersion? Could the motion of star clusters, sparse and subject to statistical whims, mislead in small-number tricks that vanish once more orbits are counted? Every avenue of caution was marched down, and though caveats gathered like clouds, the storm never broke into dismissal. The object remained unlikely and luminous. In the corridors of thought, where humility and ambition meet, analogies hardened into tools. The galaxy was called a ship without a keel, a cathedral built on fog, a murmuration of starlings flying in formation without any wind. Each image tried to capture the terror of a structure that had no right to stand, and yet did. But the truer image was quieter, a ledger that balanced without the long-trusted entry. Accounting is a language of belief, and balance sheets that omit assets raise alarms. An astrophysical balance sheet that closes with only the visible, stars, gas, dust, felt like a misprint. The auditors demanded receipts. The sky produced them, and still the discomfort remained. A deeper shock lived in the consequences. If one galaxy could be nearly free of dark matter, perhaps processes exist, rare, environmental, violent, that can peel luminous matter away from its halo. That would not overthrow the standard model. It would elaborate it. But if many such galaxies are found, scattered across environments where stripping is implausible, then the prologue to galaxy formation may need a new chapter in which baryons, the ordinary matter of protons and neutrons, briefly transact their lives without their usual escort. The search widened. Ultra-diffuse galaxies were scanned for kinship. Some revealed heavy halos, hiding their mass where the initial object did not. Some betrayed signs of tides, stretched isophotes, faint streams, scattered clusters. Others stood ambiguously between comfort and crisis. The shock matured into a survey. Meanwhile, the specter of selection effects hovered. The universe is a trickster that hides in the thresholds of instruments. Low surface brightness is a forest where giants can hide and dwarfs can lie. Detection pipelines can miss halos that are smooth and extended. Analysis routines can underweight the outskirts where dark matter does most of its binding. Could it be that the methods were elegant but blind in exactly the way that produced the tale of an unburdened galaxy? Teams cross-checked with alternate pipelines, injected synthetic galaxies into data to measure recoveries, and tuned their background models until systematic ghosts had fewer paths to walk. With each improvement, the core enigma resisted dilution. And yet, the clearest terror in the shock was hope. For scientists, a crack in the wall is an invitation to the sky behind it. If the galaxy stood outside expectation, then new knowledge waited on the far side of courage. Theories that alter interactions in the dark sector. Self-interacting dark matter, warm dark matter with free streaming that blurs the smallest halos, ultralight fields whose quantum pressure builds cores where cusps should dwell. Each could, in contrived corners, manufacture a luminous island where the shadow is thin. Numerical universes were born in clusters of computers, evolving billions of particles under revised rules to see whether a tide, a collision, a feedback-driven wind from young stars, or a dance of resonances could peel the dark from the light. In some runs, the exceptional was born. In others, the galaxy dissolved. The shock spread into parameter space, charting provinces where the impossible was simply unlikely. Through all of this, the galaxy went on being what it was. Stars aged in silence. Supernovae were rare, their ashes folded into new generations slower than the human heartbeat can bear. Globular clusters, those compact testaments to ancient star formation, orbited like lanterns whose paths drew the shape of gravity onto the page. Their dispersions, small, insistent, kept writing the same sentence in different ink. If one cluster lied, the chorus of them corrected the record, and if their number was small, it was still a number that refused to sing the expected tune. The shock reached the public, as such things do in the softened grammar of headlines. A galaxy without dark matter, it was said, had been seen. Some heard in that phrase the collapse of everything, others the exaggeration of clickbait. The truth, as always, was more intimate and more severe. The universe had slipped, just for a moment, out of our grasp, and the hand that reached for it found no purchase. The meaning of the slip was not apocalypse, but invitation. In the end, scientific shock is not panic. It is clarity. It is the moment a mind realizes that an assumption was carrying more weight than it should, that a habit of interpretation had become a law without a legislature. The galaxy's existence, stubborn and delicate, lifted that weight and let uncertainty breathe. Around that breath, thought could reorganize. Beware certainty, the stars were saying. We will accommodate your models until we will not. We will delight you with agreement until we must instruct you with dissent. So the shock endured, calcifying into purpose. More galaxies would be sought at the thresholds of brightness where myths and measurements trade places. Distances would be nailed down to tighter pins. Stellar populations would be dissected with photometry that pries open color magnitude diagrams like fossils. Kinematics would be measured with instruments that sip starlight through narrower straws. Lensing, though faint at such masses, would be stacked statistically to weigh the nothing that might still be there. If the galaxy remained an only child, it would be a parable. If it turned out to have siblings, it would be a revelation. Either way, the shock had done its work. It had reminded a species that love's answers, that questions are the deeper form of love. And if, in some far future, the mystery resolves neatly, if a distance error survives every audit, if a hidden tide writes its confession in a stream discovered by a better eye, if the dark matter paradigm swallows the exception by learning a new trick, it will not erase the value of this trembling. For knowledge grows most honestly at the borders, where fear and curiosity negotiate a truce. The impossible galaxy, seen and argued and pursued, has already purchased a more careful science. And if the resolution is not neat, if instead the exception leads to an amendment of gravity or a richer dark sector, or a taxonomy of galaxies stranger than the imagination that first named them, then the shock will be remembered as the soft thunder that announced a new weather in our understanding. In either case, the voice of the universe was calm. It did not raise itself to be heard. It spoke in the measured syllables of star motions and the faint grammar of low-surface brightness. It waited for those who would learn the language. They have begun to answer, slowly, with doubt as their instrument and awe as their guide. The shock is still shaking. The deeper the investigation went, the more the galaxy seemed to retreat into paradox. Each new observation, meant to clarify, only sharpened the mystery. Telescopes stared longer, peeling away the veil of noise. They measured the brightness of red giants, the colors of star clusters, the faintest signatures of gas. And yet, every clue pointed to the same unsettling conclusion. The galaxy's stars moved with the rhythm of a system bound only by their own mass, with no hidden hand beneath them. A cosmos that was supposed to be scaffolded by dark matter had revealed a place where that scaffolding appeared absent. The measurements were scrutinized with almost forensic obsession. Astronomers tested the distance again and again, for if the galaxy were closer than believed, the paradox would dissolve. But the ladders of distance held. Standard candles flickered at the expected luminosities. Surface brightness profiles aligned with what the equations demanded. The galaxy was as far as they said, and thus as large as it seemed. Its dimensions were not tricks of perspective. Velocity dispersions were recalculated. Perhaps the stars chosen for analysis were too few, too misleading, their statistics distorted by chance. New candidates were measured. Globular clusters were tracked, their paths mapped against the void, but whether through starlight or cluster, the result was the same. The mass was not enough. This left astronomers with two grim possibilities. Either the galaxy had somehow been stripped of its dark matter, its invisible bones pulled away by an encounter with a larger neighbor, or else the entire framework of dark matter itself was incomplete, unable to account for exceptions that refused to vanish. The first explanation was easier, safer. Tidal stripping was a known process, one that could, in theory, separate stars from their halos. But evidence for such violence was faint at best. The galaxy showed no great scars, no long streams of displaced stars trailing behind it. If it had been robbed, the thief had left almost no mark. The second explanation was far more dangerous. If dark matter was not universally present, if galaxies could form and survive without it, then perhaps the idea itself was flawed. Perhaps dark matter was only the shadow of a deeper law yet unspoken. Some whispered of modified gravity, of equations that bent differently at the faintest accelerations. Others imagined dark matter that was not monolithic but mutable, slipping away under conditions we had yet to imagine. Each idea was bold, but none could yet claim victory. The galaxy hung in its silence, as though indifferent to the turmoil it caused. Its stars burned faintly, unaware that they had become witnesses in a trial against the universe's most trusted theory. To the human mind, paradox is unbearable. To the cosmos, paradox is only truth not yet understood. The more they looked, the more it seemed the galaxy was not alone. Other faint, diffuse systems revealed their own peculiarities. Some bore heavy halos, others appeared suspiciously light. A pattern hinted at itself, though incomplete, a whisper that galaxies might not all be born equal, that the paths from gas cloud to starlight were more varied than the textbooks claimed. The deeper the investigation, the deeper the unease, for every new answer sharpened the question. Was this an exception, or the first hint of a hidden rule? If one galaxy could exist without the invisible weight of dark matter, then the universe had just told us that certainty is a mask, and behind it waits the infinite. The search for resolution became relentless. Astronomers turned the most powerful instruments of their age toward the ghost-like system, each hoping that more light would erase the paradox. Hubble's steady eye probed the stellar populations with precision, teasing apart the faint red giants from younger, bluer stars. Their ages suggested a system old and quiescent, as if it had drifted undisturbed for billions of years. That serenity clashed with the idea of a galaxy violently stripped of its dark matter. A tidal encounter should have left chaos. Streams of stars flung into intergalactic night, shells and scars etched into the outskirts, but here the stars glowed in quiet order, thinly scattered, fragile yet composed. Attention shifted to globular clusters, those ancient orbs of stars that act as messengers of mass. If dark matter were hidden, their motions would betray it. Dozens were measured, their paths traced like beads on invisible threads. Yet their dispersions echoed the same verdict. The galaxy's weight was no more than what its stars provided. The clusters orbited a hollow system. The dark skeleton was absent. Simulations ran in supercomputers, digital universes recreated with altered parameters. They tested scenarios where a galaxy could be robbed clean by a neighbor, its dark matter peeled away while its stars survived. Some runs produced ghosts like the one observed, but the violence required was extreme, the circumstances narrow, the probability low. Others tested new physics, dark matter that self-interacts, colliding softly with itself, capable of being displaced while baryons remain. Some tested alternative gravities where the laws bent at low accelerations, mimicking the absence of dark matter. Each simulation birthed possibilities, but none produced certainty. And so the galaxy stood, an open wound in cosmology. To some, it was a challenge to sharpen theory. To others, it was a warning that we may not yet understand the universe's deepest grammar. For if galaxies could exist outside the shadow of dark matter, then perhaps the great invisible scaffolding was less universal than believed. Or worse, perhaps the scaffolding itself was an illusion. Through it all, the galaxy shone faintly, its stars uncaring of human struggle. The light they cast was ancient, older than humanity itself, older than Earth's continents. It had traveled across time to deliver a riddle, not an answer. To look upon it was to feel the old truth rise again. The universe is not obliged to confirm our expectations. It exists first and explains itself later, if at all. The anomaly did not vanish with scrutiny. Instead, it multiplied, echoing across the minds of those who sought to explain it. For in science, when one exception appears, it is not merely an oddity. It is a seed of doubt that grows in every direction. And so the mystery escalated. If galaxies could exist without dark matter, then perhaps others waited, hidden in surveys, faint and diffuse, their paradoxical light overlooked in the noise of the sky. Teams turned to archives, searching through catalogs with fresh eyes. Algorithms were tuned to catch structures that had once been dismissed as artifacts. The universe, vast and unsparing, began to yield candidates, other faint systems whose stars whispered of impossible dynamics. Some showed hints of missing halos, others bore masses that clashed with their light. The single paradox began to look like the first of a lineage. The implications deepened. Cosmology had long been a triumph of prediction. The cosmic microwave background, mapped in exquisite detail, had told the story of matter and energy with uncanny accuracy. Simulations built on that foundation had reproduced the web of filaments, the clusters and voids, the distribution of galaxies across scales. Everything seemed coherent, consistent, almost inevitable. But inevitability is fragile. One galaxy without dark matter is a curiosity. A population of them is a fracture. If these galaxies were stripped remnants, then stripping itself must be more common, more efficient, more precise than imagined. If they were born without halos, then formation is not as universal as theory insists. If they were evidence of new physics, then the very backbone of cosmology was bending before our eyes. Each possibility was unsettling, for each required rewriting the story of creation. What made the escalation terrifying was its simplicity. The galaxy did not explode. It did not shine with exotic energy. It did not behave violently. It was quiet. It was ordinary in its stars, its chemistry, its shape. What made it extraordinary was only its refusal to obey. That refusal struck deeper than spectacle. It was not a firework in the sky, but a flaw in the map. The more scientists stared, the more the unease spread. What if our models, so carefully tuned, so elegantly precise, were brittle in ways we could not see? What if the universe was far more permissive in its architectures than the equations allowed? To imagine such a possibility was to imagine a cosmos not of strict order, but of exceptions, improvisations, and quiet rebellions. And so the mystery escalated, from a faint smudge of light into a question vast enough to unsettle the foundation of physics itself. A galaxy that should not exist had shown us that the universe is not bound to the laws we write. It is bound only to itself. The escalation took on new gravity when comparisons were drawn between the impossible galaxy and its cosmic neighbors. For galaxies do not live in isolation. They orbit, collide, merge, and tear at each other with tides invisible but immense. To understand one is to understand the context of its family, and so astronomers widened their gaze. What they saw deepened the paradox. Near the ghostly system lay a brighter, more massive companion, a galaxy large enough to disturb its neighbors with gravitational tides. If the faint one had been stripped, this companion was the prime suspect. The scenario was tempting. A massive galaxy tearing away the invisible skeleton of its fragile partner, leaving behind stars adrift, but somehow still bound together. Yet the evidence resisted closure. For tidal stripping leaves trails, streams of stars unraveling across space like spilled sand. It sculpts asymmetries, fractures coherence, pulls at the edges of systems until they fray. And while hints of disruption lingered in the faint outskirts, they were not decisive. The galaxy's stars still glowed with improbable order. If it had been robbed, the theft was too clean, too surgical to match what simulations demanded. Worse still, a twin appeared. Another galaxy, equally diffuse, equally improbable, equally resistant to the invisible weight of dark matter, was uncovered nearby. This was no longer a single accident. Two siblings, each defying expectation, suggested a pattern. Were they both victims of stripping, or were they both born in defiance of cosmological law? The mystery multiplied, like echoes repeating into the dark. Simulations were pressed harder. Galaxies collided on computer screens, their halos tearing, their stars scattering. Some models produced remnants that resembled the observed ghosts. But the odds were narrow, the circumstances extreme. To require such precision for each case strained credibility. Nature is not usually so contrived. If such systems existed, they should be vanishingly rare. And yet here they were, side by side, mocking the idea of rarity. The escalation spread to theory itself. If pairs of galaxies could survive without their halos, then perhaps halos were not as essential as believed. Perhaps dark matter clumps differently, segregates under conditions unseen, or evaporates from fragile systems. Some even dared to ask, what if galaxies are not the children of halos at all, but of processes we have not yet imagined? To ask such questions was to pull at the very fabric of Lambda CDM, the model that had reigned for decades. The faint galaxies did not answer. They did not argue. They simply existed, glowing in quiet defiance. Each photon they cast a reminder that the universe cares nothing for what we expect. The escalation was not in them but in us, in the recognition that reality had already outpaced our understanding. The mystery no longer belonged to one galaxy, nor even two. It had become a question looming over the structure of the cosmos itself. Each new telescope turned toward the diffuse systems only intensified the strangeness. Their stars were fragile, spread across vast volumes like smoke suspended in air, yet they endured. By the logic of gravity, by the arithmetic of dark matter, they should not. The escalation lay not only in the galaxies themselves, but in what they implied for the great architecture of existence. For if dark matter was not the universal glue, then every filament of the cosmic web, every cluster, every spiral, every dwarf, was called into question. If the scaffolding could be absent here, why not elsewhere? Was the universe less orderly than imagined, built not on unbreakable laws, but on probabilities, exceptions, and the possibility of rebellion? Scientists pressed deeper. Spectra were analyzed for signs of gas, for echoes of ancient feedback that might have expelled invisible mass. They searched for the fingerprints of violent pasts, for clues in chemical abundances, for stellar ages that might betray trauma. Yet the stars told a quiet story, one of age and calm. They did not sing of catastrophe. They whispered of endurance. The escalation turned philosophical. Could it be that the very need for dark matter was a projection of human desire for order? Had we mistaken the shadow of incomplete law for substance? Modified gravity theories crept again into discussion, no longer as fringe but as reluctant alternatives. Perhaps galaxies were not testaments to hidden scaffolding, but to a gravity that bent differently when weak. Perhaps the cosmos was not lying. It was speaking a dialect of physics not yet translated. Each possibility was heavy with consequence. If dark matter was incomplete, then decades of cosmological triumphs would need reweaving. If galaxies could live without it, then our map of creation was only half drawn. If gravity itself was different, then Einstein's elegant fabric was not the final weave, but only a prelude. The escalation was not noise, it was a deepening silence, an awareness that the universe had paused to remind us. Certainty is always temporary. A galaxy that should not exist had become a mirror, showing us the fragility of knowledge itself. Theories rose to meet the paradox, like tides against a cliff. No scientist could let such a wound in cosmology remain untended. If the galaxies stood in defiance of dark matter, then the task was clear: to imagine worlds in which their existence was possible. Some theories leaned on the violence of history, others on the pliability of nature itself. All were attempts to explain how the impossible had become real. The first was the theory of stripping. Perhaps these galaxies had once been ordinary, swaddled in their dark halos like all the rest, until they strayed too close to a massive neighbor. Gravitational tides could reach deep, pulling away the invisible halo while leaving stars intact, like a skeleton torn from flesh while the shape remains. Simulations showed such events could happen under rare circumstances. galaxies colliding, merging, peeling matter like rind from fruit. But the neatness of the observed systems defied this brutality. If they had been stripped, why were their stars so calm? Where were the streams, the scars, the chaos of survival? Another explanation whispered of self-interacting dark matter. In this vision, the invisible particles did not pass silently through one another, but collided, scattered, even bled away under pressure. If halos could leak, then perhaps some galaxies had been hollowed out by physics deeper than the cold, collisionless picture. This theory gave dark matter more life, more substance, transforming it from silent scaffold to active participant in cosmic history. But evidence was thin, and the behavior required was delicate, tuned to match some galaxies while sparing others. Others revived the old ghost of modified gravity. Perhaps there was no dark matter at all, only a flaw in the way we wrote the law of attraction. In the realm of faint accelerations, maybe gravity grows stronger than Newton and Einstein declared, producing the illusion of hidden mass. If so, then these galaxies might reveal the opposite. Systems where the illusion failed, where gravity played its true, unmodified hand. The idea was bold, elegant, and heretical. It explained much, yet stumbled in the face of galaxy clusters and the cosmic microwave background, where invisible weight seemed undeniable. Still, for some, the paradox reopened the door to this radical vision. Speculations multiplied. Could feedback from supernovae or black holes have driven dark matter away, reshaping the halo? Could early conditions in the universe have birthed galaxies without halos at all, rare anomalies born in silence? Each idea strained, but each was tested, for science thrives not on certainty, but on doubt made rigorous. What bound all these theories together was not their differences, but their admission of humility. The impossible galaxy had forced even the most confident to bow before mystery. For in its faint glow was written a simple truth. Reality does not answer to our expectations. It only waits for us to learn its deeper name. Speculation turned into a battleground of possibility, each theory trying to wear the crown of plausibility. The stripping scenario still lingered in discussions, for it was the least radical, the most compatible with the cosmos we thought we knew. If a larger galaxy had stolen the dark halo of its fragile companion, then the paradox was less a revolution than a crime scene. Yet every simulation that produced such a clean theft required precision bordering on the miraculous. Two galaxies must approach at just the right angle, with just the right velocity, in just the right environment. Nature rarely obeys such choreography. The notion of self-interacting dark matter continued to tempt. Unlike the cold, silent particles imagined for decades, this vision allowed for complexity. Dark matter particles colliding softly, scattering energy, redistributing themselves. Such behavior could hollow out a halo without tearing stars apart. This would not only explain the ghost galaxies, but also account for long-standing puzzles, such as why the cores of dwarf galaxies appear less dense than expected. But giving life to dark matter in this way required rewriting its essence. It was no longer invisible scaffolding, but a substance with character, one that behaved differently across scales. The evidence remained incomplete, but the seduction of a richer dark sector was strong. Modified gravity clung stubbornly at the edges of debate. For decades, it had been pushed aside by the overwhelming success of lambda CDM in predicting the cosmos. Yet now, as galaxies defied the need for halos, the idea gained breath again. Perhaps gravity was not universal, but conditional. Perhaps the cosmos bent differently at the edges of weakness, the way light bends differently in glass than in air. These galaxies could be places where the hidden hand of dark matter was not missing, but unnecessary. The elegance of this vision was undeniable. Its danger was equal. And then there were wilder visions still. Perhaps we were glimpsing not galaxies at all, but fragments of a deeper multiverse, places where physics itself had taken a different turn. Perhaps dark matter could decay, evaporating slowly across aeons, leaving behind luminous husks. Perhaps quantum effects on cosmic scales played roles we had not yet written into law. Each speculation widened the horizon. Each admitted that we still stand on the shore of understanding. Theories did not resolve the paradox. They multiplied it. For every path toward explanation, another question unfolded. What these galaxies truly revealed was not a single truth, but the vastness of possibility that lies between ignorance and knowledge. The debates grew sharper, but also more creative. Each hypothesis seemed to explain one thread while letting others slip away. Stripping offered a history of violence, yet left unanswered the serenity of the stars. Self-interacting dark matter promised a richer physics, yet demanded interactions fine-tuned enough to escape other observations. Modified gravity carried elegance, but strained under the weight of the cosmic microwave background. None stood without fracture. Some astronomers proposed a hybrid vision, one in which multiple truths overlapped. Perhaps dark matter exists, but not in a single, simple form. Perhaps some galaxies are born with fragile halos, easily torn by tides, while others nest within halos as dense as stone. Perhaps the laws of gravity bend slightly at low accelerations, but only in ways subtle enough to masquerade as dark matter most of the time. Such compromise was unsatisfying to purists, but the universe has never promised purity. Attention turned again to the stars themselves. Their ages, their metallicities, their distributions became witnesses in the trial. If the stars were old, then the galaxy had endured for billions of years without its invisible skeleton. If young, then perhaps it was a transient, a structure not yet tested by time. Observations leaned toward age. Ancient stars, some nearly as old as the universe itself, populated the ghostly expanse. This deepened the paradox. How had a fragile, unanchored system survived for so long in a universe of collisions and tides? Some turned to feedback, the cosmic winds driven by supernovae and black holes. Could these eruptions have expelled dark matter as well as gas, reshaping the halo? Models struggled, for dark matter does not couple easily to energy in the visible sector. Yet whispers of exotic physics, dark matter interacting through hidden forces, kept the door ajar. What bound the debates together was not consensus, but awe. The galaxy had forced cosmology into humility, compelled it to admit that its foundation might be less solid than believed. And in that humility lay a strange beauty, for it is in the cracks of certainty that wonder grows. The impossible galaxy had not given us answers. It had given us more questions, and in those questions, a reminder that the cosmos is not ours to tame. It is ours to pursue. The paradox demanded sharper tools. Telescopes became detectives, each instrument tasked with interrogating the galaxy more deeply than before. Hubble, with its patient eye above the atmosphere, dissected star clusters and traced their dispersions across the void. Keck and VLT gathered spectra, parsing velocities into whispers of gravitational weight. The Dragonfly Array, designed for low-surface brightness light, revealed the ghostly outlines invisible to traditional surveys. Each observation tightened the frame of reality, and still the mystery held. Then came the promise of James Webb. With its infrared gaze, it could peer into the oldest, faintest stars, measuring ages with unparalleled precision. If the galaxy's stellar populations proved ancient, then it had endured unanchored for billions of years, a miracle of survival. If younger, it might be ephemeral, a fleeting quirk of cosmic evolution. Webb's detectors opened that window, and the results leaned toward age. The galaxy was no passing shadow. It had been there almost since the beginning. Meanwhile, simulations absorbed the anomaly. Supercomputers constructed digital universes, evolving billions of particles under rules old and new. Some runs created galaxies stripped to their bones, survivors of violent tides. Others produced fragile halos that lost coherence under exotic interactions. Each model, each code, was compared to the quiet glow of the observed system. None fit perfectly, yet each chipped away at ignorance. Science advanced not only through telescopes, but through collaboration. International teams compared data, cross-checked assumptions, recalibrated distances, hunted for hidden biases. The paradox became a global effort, a shared pursuit across continents and disciplines. The impossible galaxy was no longer just an object, it was a crucible for cosmology itself. What instruments revealed most clearly was not resolution, but scale. The galaxy was fragile, faint and rare, and yet it was enough to force humanity to point its sharpest eyes and brightest minds toward it. This was the true power of the impossible, to draw us deeper, to make us sharpen every tool in the pursuit of a truth still out of reach. The tools sharpened further, as though the universe itself had challenged humanity to prove its patience. Astronomers turned to gravitational lensing, hoping that the faint galaxy might bend the light of background objects and reveal its true mass. But the system was too delicate, too insubstantial to leave clear arcs. The absence of distortion echoed the same refrain. No hidden weight lurked in its halo. Attention shifted to radio telescopes. If gas traced the invisible, then mapping neutral hydrogen might betray what stars could not. Arrays like ALMA and the VLA tune their ears to frequencies that carry the whispers of cold gas stretched across time. Yet the galaxy was nearly silent in radio, as though its reserves had long been exhausted. It was not being actively reshaped by tides or feedback. It was simply faint, old, and strangely hollow. Computer models grew bolder. They tested exotic physics, dark matter that interacts with itself, or with hidden fields producing halos that dissolve under rare conditions. They tested scenarios where ordinary matter, through feedback from stellar births and deaths, pushed dark matter outward, leaving a luminous shell. They even tested modified gravity, asking whether the faint system could survive under laws bent differently than Einstein's. Each produced fragments of plausibility, but none provided the whole. The galaxy remained a riddle that refused to collapse into solution. Meanwhile, surveys widened their net. New instruments searched the sky for other ghost galaxies, faint smudges that might carry the same paradox. Some were found. A few echoed the anomaly. Most did not. The diversity itself became part of the puzzle. Why should some galaxies play by different rules? Why should the universe allow exceptions at all? The tools had done their work. They revealed stars, clusters, gases, and motions with exquisite precision. They confirmed the anomaly was real, but they did not explain it. The cosmos had offered its faint whisper, and even with our sharpest ears, we could not yet translate its full meaning. The investigation pressed on, now less about proving the galaxy's existence than about testing the boundaries of our own imagination. For once, the data hardened into fact. The question shifted. How far could we stretch our tools, our theories, our patience, to meet the cosmos on its own terms? New missions were designed with these whispers in mind. The Vera Rubin Observatory, soon to survey the entire sky night after night, promised to reveal faint galaxies in their thousands. If more anomalies lurked, Rubin would find them. Euclid and the Nancy Grace Roman Space Telescope prepared to chart dark energy and dark matter through the grand lens of structure formation. In their vast maps, the ghostly outliers might finally be placed within a larger story. Particle physicists, too, joined the hunt. If the galaxy hinted that dark matter behaved differently than believed, then experiments on Earth might catch a glimpse of its true nature. Deep underground detectors waited for particles to strike xenon or argon with subtle flashes of light. colliders pushed matter to energies where shadows of the unseen might emerge. The faint glow of a galaxy, billions of light-years away, was now linked to the hum of machines buried beneath mountains and deserts. Theories grew speculative, yet disciplined. Some imagined a multi-component dark sector, as rich and varied as ordinary matter itself, with particles that clumped, scattered, or slipped away depending on their properties. Others imagined galaxies as laboratories of new gravity, each faint system a test particle in spacetime's hidden equations. Still others spoke of early cosmic conditions, fluctuations in density that seeded some galaxies in ways rare and fragile. Through it all, the galaxy continued to shine faintly, its stars indifferent to the debates they had ignited. The tools had reached their limit. The data was real. The paradox remained. And in that endurance lay the quiet power of science, that sometimes the pursuit is not to end the mystery, but to live within it until the universe decides to speak again. The paradox was never only about galaxies. It was about us, about the way we seek order in a universe that may never be ordered in the way we hope. The impossible galaxy had forced cosmology to stare into its own reflection, to admit that its scaffolding might not be universal. And in that admission, a deeper question emerged. What does it mean for humanity when the cosmos proves stranger than its equations? Philosophers of old once warned that certainty is the enemy of wonder. Here, in the faint light of a galaxy that should not exist, that warning became prophecy. Every model had been built to tame the stars, to pull their motions into the gravity of equations. Yet the galaxy refused to be tamed. It was not chaos, it was coherence of a kind we could not yet name, and that is more unsettling than disorder. For disorder admits defeat, but order without explanation is a reminder that reality is larger than thought. In its silence, the galaxy carried a lesson, that the universe is not bound to reveal itself in neat answers, that truth is sometimes written in contradictions, that knowledge is never final, but always provisional, fragile, temporary. Humanity's maps may grow more detailed, its models more intricate, its instruments sharper, but the cosmos is always ahead, already waiting with another riddle folded in the dark. The galaxy was not a threat. It was not a herald of doom. It was simply a reminder that we are still at the beginning, that the night sky is still a book only partially opened, that our longing to understand is itself part of the mystery. To gaze upon it is to feel the humility of our place, small minds on a small world, staring into infinities that do not bend to us. And yet, there is beauty in this. For in the refusal of the cosmos to conform, we are given an endless horizon. We are given the gift of never-ending questions. We are given the chance to pursue wonder without end. The light that reached us from the ghost galaxy was ancient, millions of years older than our species, older than the first spark of fire in human hands. To think of it is to imagine photons traveling patiently, crossing voids so wide that human history itself fits into their journey as a footnote. And when at last those photons fell into our detectors, they carried not certainty, but paradox. They carried the revelation that the universe is not finished, surprising us. The scientists who studied them wrote papers, gave talks, debated theories. But beyond the walls of observatories and universities, the meaning was larger. For every human who looks into the night sky and asks why, this galaxy is an answer. Not of closure, but of invitation. It says, the universe is deeper than your understanding, but you are welcome to chase it. In its faint glow lies a metaphor for all discovery. The greatest mysteries do not announce themselves in brilliance. They arrive quietly, hidden at the edge of perception, waiting for patience to notice them. And when we finally see, they change us. They do not make us certain, they make us humble. They remind us that to be human is to live inside questions that will never end. Perhaps one day the paradox will dissolve. Perhaps new physics will explain the missing halo, or new surveys will prove such galaxies common. Perhaps the impossible will become ordinary. But even then, the memory will remain of a moment when the universe looked us in the eye and reminded us that it does not belong to us. We belong to it. The galaxy remained serene and indifferent long after our debates had burned themselves into exhaustion. Its stars continued their quiet drift, ancient embers glowing in defiance of all prediction. And perhaps that is the truest meaning of its existence, not to shatter our knowledge, but to show us how fragile knowledge always is. For centuries, humanity has believed that the universe could be mapped, charted, and explained, that every star could be folded into a law, every galaxy into a model. Yet here was proof that reality is not so easily subdued. One faint, fragile system had forced us to rewrite our certainties, to admit that mystery is not a flaw in science, but its fuel. The galaxy should not exist, and yet it does. That simple contradiction is a mirror for our own condition. We too should not exist, not by the cold arithmetic of cosmic chance, not by the violent history of stars and planets. And yet we do. We think, we wonder, we look up into the night and demand answers from infinities that do not bend to us. In the glow of that distant system, we see both our ignorance and our persistence. Perhaps this is the role of such galaxies, to remind us that the cosmos is not a solved riddle, but an endless poem. Its verses stretch across time, each line written in light, each stanza in silence. Some lines we can read, others remain beyond our reach, but the poem continues, whether we understand it or not. And so the story closes where it began, not with certainty, but with awe. A galaxy that should not exist, but does. A universe that continues to resist conclusion, and a species that will keep looking upward, humbled and transformed, forever chasing the impossible light.